Morning. Thanks for joining. Let's wait a minute and then we'll start with our Knative workshop. Just let's wait a few seconds. So meanwhile, I've put some important links on the chat to your right. We'll follow first those links, and the best thing is to start signing up and getting an IBM Cloud account if you still don't have such an account. So let's wait a few more seconds and then we'll start. Okay, so good morning. It's good morning for me, good afternoon, wherever you are. Thanks for joining to our Knative workshop. My name is Yafa Steinbock, and I'm a developer advocate at IBM Israel. And together with me, actually, who's moderating this session is my colleague Tal Neeman, who's also a developer advocate. And while I'll be presenting, he will help us make sure that this event will work properly. If you have questions or issues, please write them on the chat, and he will let me know if there's something that I should notice or if I could go forward. So today we'll start with a short presentation with a short introduction about what is Knative, and then we'll do a workshop that you can follow and then run by yourself. So before we start, here are some important links that I also put on the chat to the right. The first one is a link to a Git book where you can see my presentation and also the labs. The second link is a sign up for an IBM Cloud account, and I would ask you all, if you don't have such an account, to currently go and get yourself an account like this. So please go in and get yourself an IBM Cloud account. After that, we will create a service, and it will look like that. Just a second, I have some issue with my mouse. Okay, better. So this is a link for my Git book where you can see my presentation and instruction for the lab. The first thing is that you should do is register and get yourself an IBM Cloud account, and you should follow some steps to do that. And then, sorry, my mouse has some issues. Wow. And after you get yourself an IBM Cloud account, you will get to the IBM Cloud dashboard, where you will be able to see all your services that you currently have, which you probably don't have any, but I have a few. And from there, you should go to the catalog. You should click on the catalog, and you will get to where you can choose which services you would like to create and deploy for yourself. So as an example, we start today with a natural language understanding. So please write natural language understanding and you will find this service. Click on that, and then you will find yourself in the screen that helps you create your service. And from here, you can pick a location where you would like this service to be created. You can stay with Dallas or pick yourself another location. We'll choose the light account, which does not cost anything. And also you can decide on the name of the service or keep it like that and click on the create service. After a few seconds, you will get your first service, which is natural language understanding, and it's a service from Watson family that helps you understand the language, understand text. And here you can see when you go to the manage, you can see your credentials and the URL to call this service. And going to getting started, you get to see how you can call this service and work with it in a second. So here's an example to run with a curl command, just putting your API key and the URL that we just saw in the credentials that are here. So you need to get your API key from here and the URL. And when you run and call your service with your API key and URL, like in this example, you can play and see how a natural language understanding works. So this was just a small example of how easy it is to create services and work with them on the IBM cloud. And by the way, by the end of the workshop, I would appreciate it if you could please answer a short survey, and this is a link for the survey. So as we managed to create a service really easily, here is a list of services that we have on the IBM cloud and you can work with. Some of them are with a freemium plan, meaning that you can work with them with your light account that you just created. Some of them need a better cloud account, an account with some credits, or even if you put your credit card, like for instance, Kubernetes cluster on OpenShift. But don't worry, for the sake of this lab, we will give you a way to create yourself and work with an OpenShift cluster that you can use for a few hours and play with Knative. So even though OpenShift is a service that requires either credits or a credit card, because it's a service that costs some money because of the need of many resources. But for the sake of this lab, we will get you a way to create yourself and acquire an OpenShift cluster that you can play with for a few hours, something like 3 or 4 hours. And after that, this service will shut down, but you will be able to create another one and play with it for another 4 hours and again and again. Okay, so if I didn't introduce myself, so my name is Yafa Steinbock, and I'm a developer advocate and also working in what is called IBM Alpha Zone Accelerator. And in both positions, we work with developers, either like doing hackathons, workshops, webinars like today, or working with startups to help them build an enterprise a solution for their startup. So I do both things, both as a developer advocate and also as an architect. And if you would like to hear more about us and join more sessions, you could go either to to our meetup group, which is IBM Startup and Developer Tel Aviv, or to the IBM Developer Europe link of Crowdcast, where you can get also to join to next sessions of our whole European team, or even listen to recording from previous sessions. So today we will talk about Knative, which is a Kubernetes-based platform to deploy and manage modern serverless workloads. So to set the stage where we are, so we are working with containers, and we need a way to deploy them on a Kubernetes cluster. So usually the process works like this. Deborah, the developer, developed her code, and now she is ready to deploy it. So what she first needs to do is first encapsulate and close her microservices in what is called containers. So for that, she first creates a container image, which is a template of containers. So for that, she needs to declare a Docker file that describes how she wants this image to look like. After that, she runs a container build command or Docker build command that builds her image, takes this image template and pushes it with a push command to a registry where you can have container images that others can take and deploy on a Kubernetes or OpenShift or wherever containers could be run. The next step is Mike, the operation guy. He pulls the container images and then runs them with a container run, Docker run, Podman run command in a Kubernetes cluster. So again, first Deborah develops her code, develops her microservice, creates an image template, builds it, pushes it to a registry, and then whoever wants to deploy it needs to push this image and run it on an orchestrating tool like Kubernetes or OpenShift. But deploying it running it on OpenShift needs some knowledge, because we need to know how Kubernetes works. We need to be able to actually tell Kubernetes how we want to run those containers. So we need a way to talk to Kubernetes, and we need to learn how to work with it, and we need to learn how to either work with the interface like OpenShift cluster, or to use CLI commands like kubectl commands for Kubernetes, or OC commands for OpenShift. And we need to know how to tell Kubernetes what we want to run and actually how we want it to work. So if we are talking about Kubernetes, we need to declare some resources. Like in this example, if we want to, let's say, deploy a microservices, let's say hello world, that will run two containers simultaneously, two copies of containers. So we need to first to tell Kubernetes that to define what is called a deployment. And we, for instance, here you can see that we tell Kubernetes, look, we want to use an image called a hello world, and we want it to run with two copies, two replicas. And we need to declare which port will he listen to, etc., etc. And then after we define this deployment, we also need to define the service. how we would like to externalize, how we would like to expose this deployment to the world. So we need to define another resource that is called service. And for here, for this example, we declare a resource called service, and we defined it that it will work in a load balancing way, and it will be exposed with port 80, and the container itself, the deployment resource, will listen to port 8080. And this is only a simple example of the resource that we need to declare to Kubernetes. And we need to, of course, declare more resources. And we need to learn this language of kubectl and the idea of YAML files that declare this resources like containers, like deployment, like services. And of course, there are more resources that we need to learn about. So in other words, we need to do a lot of things, and we need to learn a lot of things, and we need to take care of a lot of things, like resources, like what are containers, what are pods, when we run that we are running containers inside of them in the Kubernetes cluster. What are replica sets? What are deployment services, endpoints, secrets, and all those resources that we need to take care of. Also, we need to learn about other toolings, like how to create a YAML file that declares our resources. We need to learn about Helm charts. We need to learn kubectl language, etc., etc. And at the end, we find ourselves not only writing our code, but taking care and managing a lot of resources, and need to learn more toolings just to deploy our code, and so it will run properly on our production environment. And at the end, we just want to code. We would like, actually the promise of the cloud computing was that there will be a higher level of abstraction. We don't want to take care about all those infrastructure. We just want to code. So for that, we have Knative that will give us an even higher level of abstraction than what we know until now, and will enable us to focus more in our code, and even less than what we know until now, with resources and tooling just to deploy our containers in Kubernetes. So the idea here is that we as developers would like to just write code, and we don't want to care about how to build container images, how to upload them to a registry, how to deploy those containers as services, how to expose them to the internet. And we just want to code. So this will be actually, this dream could be real with Knative. So the idea is that Knative is an open source project that is above Kubernetes, and will help us to do that. So for us as developers, we will use Knative just to simplify the way we work, to make us focus on the code, and the other things will be much more easy than until now. And Knative will help us deploy our apps in an easy way. For operators like IBM Cloud, like Amazon, Google, Microsoft, etc., there will be also an option to use Knative and to add more services above it, and we'll mention it later. Another thing that comes in also is the idea of a serverless usage model. Not only that we are looking for a tool that will ease things up for us. So we will just focus on the code, and the deployment should go really smooth and easy without any, almost without any concerns and knowledge about resources in Kubernetes. The other idea is the idea of serverless. We actually don't want to think about servers. We only want to pay for real usage and not even for to create a cluster by ourselves and pay for it. We actually are looking for a way to deploy our containers, to deploy our service in a way that we don't want to care about servers. We want our containers to be deployed somewhere and run when they are called, and when they are not needed, they should not exist. And also, we want to pay for our real usage and not for a whole cluster that is not always used. Another thing is the idea of event-driven, that we want to make a connection between an event that happened and something that will run when this event was shot. And of course, we want everything to be portable, so we would like to be able to deploy easily our service everywhere that there is, let's say, a Kubernetes cluster or a Knative instance. So Cloud Native Computing Foundation says that serverless computing refers to the concept of building and running applications that do not require service management. It describes a finer-grained deployment model where applications bundled as one or more functions are uploaded to a platform and then executed, scaled, and built in response to the exact demand needed at the moment. Meaning, if our service now is running with 10 containers, so we will pay for those 2 running containers. When our service is almost not needed or even not needed at all, our containers running should scale down, and actually nothing should be running, and therefore for this time that nothing is running, we shouldn't pay anything. We would like everything to be serverless, and we would like to pay for what we are actually using. So these 2 ideas, first the idea of ease of use for developers, and we just want to think about our code, and we want an easy way to deploy our functions, our services. This is one notion. The other one is the idea of serverless. So those 2 ideas come to life with Knative, and this is a Kubernetes-based platform to deploy and manage modern serverless workloads. And Knative components are built on top of Kubernetes. This is abstracting away the complex details and enabling developers to focus on what matters. And this is built on best practices shared by successful real-world implementation. Knative solves the boring but difficult parts of deploying and managing cloud-native services, so you don't have to. So, Knative is actually an opinionated and simplified view of application and container management, and it allows developers to focus on coding. So actually this project is built on what is called best practices of companies like Google, IBM, OpenShift, and others. And this Knative is, for the major part of, or let's say the most known and most used and ways of deployment for, let's say, common things. And it allowed us to really focus on coding. And this is an extension that is built on Kubernetes. So it's still Kubernetes under the covers, and you can still access the full Kubernetes if needed. And also you can integrate between workloads that are using Knative or not using Knative altogether. In other words, you can use Knative, when it's best for you, but there's always this Kubernetes, so you can keep on working with Kubernetes with kubectl as you known for before. And if you prefer, you can move to Knative or combine those two capabilities. And also, this will be also a building block for cloud providers to create services based on Knative. And for example, IBM is a service called IBM Code Engine that even simplifies and gives a very nice user interface for developers. Take their code and tell Code Engine, this is the code, please do the rest for us. So Knative is the base for that. And there's even another layer called IBM Code Engine service that even simplifies things more than before. So if you use Knative, you need to have an OpenShift cluster or Kubernetes cluster, and then this install Knative on this cluster. And from this point on, you can use Knative or Kubernetes both and together. And if you would like to even get even bigger abstraction of the thing, you can use a service that is called IBM Code Engine, that, by the way, we'll have a session on that on the 17th of March, if I remember correctly. So this service even enables you even knowing less, meaning you just create this service. You don't own actually a real cluster, but you can deploy your code and tell the IBM Code Engine, this is my code, I want you to run it for me, and I don't want even to know about the idea of a Kubernetes cluster or OpenShift. So we will work today with Knative, that is installed above Kubernetes or OpenShift, and you will need to install Knative on the OpenShift cluster. And of course, there will be instruction for that in the lab. But if you want to even get things easier for you are more than welcome to use IBM Code Engine, that you don't even need to create yourself a cluster and to install Knative on that. So let's see more about Knative. So Knative actually covers the idea of building containers, of serving, meaning running your containers in the way needed, and even connecting between events and serving. It is a common API interface and runtime environment for serving workloads. It focuses on modern deployment patterns, and I would say the common deployment and development patterns. It implements learnings from over 50 companies that contributed to this project, meaning, again, it's the most known and common deployment and development practices. And it's portable because you can install Knative on Kubernetes or OpenShift wherever you have a Kubernetes cluster, even if it's on your on-premise, if you have Kubernetes or OpenShift, or if you are using OpenShift or Kubernetes service from IBM, Amazon, Google, or whatever. Wherever there's Kubernetes and OpenShift, you can install Knative and use it. So it's portable in that way. By the way, the idea of building container images was part of Knative, but it is now part of another project, Tecton. But for instance, if you use IBM Code Engine, also the idea of build will be brought to you by this IBM Code Engine. So let's see how this works. So let's say, and let's see the model. So when we deploy our application, we actually create a new revision. A revision has a specific configuration. It has the image that we want to run. We tell Knative this service will run using a specific container image. These are the environment variables, and also how we want this service to scale up and down. So when we create the service, we create a new revision. And when we create a new revision, we also immediately get an endpoint, how this service will be exposed to the world. When we create a new revision, and also when we create a revision, it is scaled automatically out, up and down, based on the load, based on the request, based on how much users and apps are calling our service. And it can even scale down to 0. But we can also tell it that the minimum, let's say, will be 2 containers running. But if not mentioned, so it will even go down to 0 when no one is calling this service. So as I said, when we create a service, we create a service that declares the endpoint, the image, the environment variables, and how we want things to scale up and down. Automatically, we get an endpoint, and the revision will scale up and down according to what we declared and what is needed. When we create a new revision, meaning, let's say, we say that we want this service now to work with a new container image, we create a new revision. And automatically, Knative will auto migrate to the new revision, and little by little spin off, spin down the old revision with the old containers. And this will be done automatically, and the new revision will now be connected to the endpoint. And also, we can do another thing. We can do what is called traffic splitting, meaning, let's say that we created a new revision and we want only 10% of our customers to work with it. We want to see that this new revision is working properly. And only after we see that everything works okay, we want 100% of the traffic to go into revision 2. So we can declare how the percentages between the revision and do traffic splitting based on percentage. And also, we can declare a specific endpoint for a specific revision by creating what is called a tag. And with that, let's say that revision 3 is new and we first want to test it. And so we declare a different endpoint for that. And only, let's say, testers or specific user will call specifically a new endpoint to this new revision. And again, only if this will work okay, we can then point it to the main endpoint. So this is the basic model of Knative. And the idea is that Knative manages all those resources for us, and we just need to tell him what we want to run, and he will manage it for us. And let's see how it works. So the CLI command for Knative is kn, And by the way, we can either use the kn CLI command or continue working with kubectl, and we'll see both options, and also you will be able to work with both options while running the lab. So if we want to create our first service, our Hello World service, we only need to tell Kubernetes really what is the image that we want to use, and the syntax goes like that: kn service create, the service name is Hello World, and we would like the image to be taken from this and that image, and that's all. And then Knative will create a service for us. Actually, he creates everything that we know from Kubernetes, meaning he will create deployment and replica set and a service and everything that we know for how to create a service in Kubernetes. He will do that for us. So we just need to tell Knative, hey, Knative, we want to create a service using this and that image. And if we look at the service that we have and run the command kn service list, we can see that we have a new service. This is the URL of it, and this service is running for the last 45 seconds. And if we call this service, we will see that if we do a kubectl get pods to see how many pods we have, we can see that we have one pod with a container called hello world and blah, 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 some letters, and saying that this is a deployment that is inside a pod. So this is the pod that we have. We have one pod. It says 2 out of 2 because there's also another small container running inside just to manage the Knative itself. But for real, we have one container inside a pod, one container from our service, from Hello World, and we can see it here is running. And what happens if we are not calling this Hello World after a few seconds? I think 180 seconds, if I'm not wrong. After a few seconds that nobody uses this service, we can see that if we want to, we are running the command kubectl get pods, we want to see how many pods we have. You can see that there's no pod on the cluster because no one is calling this service. And if we'll start using this service again, a new pods will be created for us. And even here we can see that there's even, let's say, 10 containers running in 10 pods. And after, again, nobody will use them. After a few seconds, you can see that they are starting to terminate. And at the end, again, no containers are running on our cluster. So you see, first of all, how easy it is to create a service. You just need to say simply, this is the image that I want to run. And another thing that we saw, that this service will be running, meaning there will be pods and containers running only according to what is really needed. And when nobody needs nobody calls them, there's no resource of our service, no pods, nothing is, no resource are being used on our cluster. And on the other hand, if there will be a growing demand for our service, there will be more pods going up and serving the requests that are needed. And again, when nobody is using our service, everything will go down. So the idea here is automatically scales based on request, like I just showed you. It scales out really fast and scales down even to 0. So we actually pay for the real resources that we are using. So the capabilities that we saw until now is that you can scale to zero, no pod, no memory, no payment. We can scale from zero, and actually we will see that we can declare with how many pods we want to start. Let's say it's not zero, and also what is the maximum number of containers that we would like to have, and also how this will start growing. We can configure revisions, and also this will be demonstrated in the lab. And we can do traffic splitting and eventing that we will see in a second. So the Knative service resource type, and some of them, actually all of them, you managed to see. We have the route which is the endpoint to our service. We have our revisions, and every time we create, we do some update on the service, we create a revision, and all those revisions are connected to what is called a configuration, and everything is connected to our service. And if you're interested in the resources that are created and deployed in Kubernetes, so usually when we work with Kubernetes, we had to the notion of services and pods and replica sets and deployment. And for Knative, there's the resources called route, revision, and configuration. And now let's see how we can work with Knative with kubectl and YAML file like before, but you can choose to work with either the Knative command line or with the kubectl. It's the same, and you can pick whatever you prefer. So if we want to deploy our hello world again, but this time using the kubectl command with a YAML file, we need to declare a YAML file for the Knative service. And it's also very simple. We call it hello world, and we say that the image that we want to use is hello world. And then we run the kubectl apply a command with a YAML file that we just created. And again, like before, Knative will create the service for us with all other resources below it, like the service, like the deployment, that the replica set, etc., etc. And again, after we apply this service, it will be created. If we would like to see the service that we have in kubectl, it will call kubectl get ksvc, Knative service, and we see that we have a URL for this service. This is the last revisions that was created, and also the last ready, which is the same in these circumstances. When we would like to look at the configuration, we also see the hello world, again, last created and last ready. We can look at the revisions, and revisions is every time you have a change, you create a revision. So we can see that we have here 3 revisions because we ran the kubectl get revision. I want to see the revisions that were created until now. So we see the latest revision is generation 3, and this is the revision with these initials, and you can see it's the last revisions, and there are 2 previous revisions. And when we are running the command kubectl get kpa, Kubernetes autoscaling, Knative pod autoscaling, you can see that the last revision is actually working, and the previous revisions are not being used because we are already on the 3rd revision, and the previous ones are not taking any resources. And this is kubectl get route. We can see the route of the hello world service, and we can use it and run our service. And that's all. So, and we want to see our deployments that, like we know in Kubernetes, kubectl get deployments. You can see that there's 3 deployments actually because there were 3 revisions. And again, you can see that the latest deployment is working. And the previous deployments are not working because Knative migrated to the latest revision, and the previous one, again, are not taking any resources. If we are looking at the replica set, again, we see that the latest revision, you see those XG59C revision is the one that is working, and the previous one, again, are not taking any resources. And if we want to see the pods that are running, again, we can see that the revision with the XG59C is running. Only those pods are currently running. It's actually one pod with one container. And there's no pods from previous revision. And okay. Now, if we would like to do a pod auto-scaling with a Knative, and this example is actually with a kubectl command, but it can be done with the kn CLI as well. So if we want to do a Knative pod autoscaler, we can declare the service again in a very simple way, saying that we want to use this image. But this time, the auto-scaling will work like that. The minimum scale is 2, meaning there will be a minimum of 2 containers running all the time. We don't want it to be 0. We want always 2 containers running, even if nobody is calling them. And the maximum, we want it to be 100. And it will scale up in a way that each container can serve 50 requests in parallel, but if there's more than 50 requests per container, another container will be spinned off again until 100 containers. So this is Knative pod autoscaler. And again, if we can see that many people are calling it, and here we have something like 5 or 5 containers running, and when nobody is calling them, or even minimum, there will be always 2 containers, 2 pods running, 1 container each with our service. Another way of auto-scaling is actually a horizontal auto-scaling that we know from Kubernetes, but we can declare it in Knative as well. And here we want to do the auto-scaling according to the CPU used by the service. And if there's more than the CPU goes be above 85, there will be another pod, another container spinning up. And if you look at the kubectl get horizontal pod autoscaling, you will see that there's more container according to what is needed. We will also see how to do traffic splitting and tagging. Traffic splitting is for how to split the work between 2 revisions, and you will play with it in the lab. And also when using tagging, and here this example is using the kubectl and YAMLs, and in the lab you will do it with a Knative command. You can tag a specific revision in a way that you give it a specific route, so you can specifically go to this specific URL. So if the URL, the route of the service normally is this one, hello world default, blah, 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 you add tagging with like say V1 and V2, and you get 2 more URLs with V1 and V2, and you can specifically call those revisions specifically with a URL, and we'll play with it in the lab. And now for the eventing, there's an option to connect between our service, the service, and between an event that happens. And this is done in a way that if a certain event happens, a trigger is fired and is calling and subscribing and actually running the service that we connected to the idea. So the idea is making a connection between an event and a service by connecting them with what is called a trigger. And there's a lot of sources available that you can create an event for, like Kubernetes, like object storage, etc., etc. But you can also create an event by yourself. And this is, for example, how to create an event, a cron event that happens, let's say, every 2 milliseconds or 2 seconds. And we call it a test cron source. So when we create this resource, we actually create an event. And if we run the command kubectl get event type, you can see that we created an event. And now we create a trigger that connects between this event and a service that will run when this event happens. So we do it by creating a trigger that says that when this event happens, we would like to run a specific service that it's called here, it's called event display. So when this event will happen, a trigger will be fired and a certain a service will be running. So what we saw until now is that Knative is, let's say, a decorated Kubernetes service, meaning it helps us, get free even more from the idea of knowing things from Kubernetes. And for the best and most common way of development and deploying services, Knative help us really go fast without a lot of knowledge of Kubernetes. It tracks revisions and configurations. It auto-scales and also can answer consumer events. It is based on Kubernetes, so you can work either with Knative or Kubernetes together. And there's the important components of serving that we saw, and eventing, and also some other stuff like the Knative client and documentation and other stuff. And if you need more resources, you can find them here. And now I will stop for a second and see if you have questions. And if not, we'll go to the lab itself. So I see there's no questions. So let's go to the lab itself. So as I told you, this is the link, the Gitbook link to my Gitbook, where you can find the presentation and also instructions for the lab. And what you will need to do is first get yourself an IBM Cloud account, which you got. The second thing is, as I mentioned at the beginning, is that you need a Kubernetes cluster or OpenShift cluster to deploy Knative above it and then use it. And since OpenShift cluster or Knative is actually a service that you need to pay for on the cloud, we have a way to give you for a few hours a Kubernetes or OpenShift cluster. So for that, you will need to click on this link, which will take you to the OpenShift labs, and you will get yourself a screen like that that looks like this. And actually, you can learn a lot about OpenShift from this Open Lab. You can run all those 6 labs. But today we'll not run those specific labs, but we'll run our lab. So for that, you will need to click to launch a lab. And actually, this will spin off for you, and as I said, an OpenShift cluster for you, just for you for a few hours. So you will click on this link, and after a few seconds, you will have a cluster for yourself, and you click on it again, and you will find yourself on your first lab. So you click on the first lab, and you'll find yourself there. And then you should go to exercise 3, to the Red Hat OpenShift on IBM Cloud Basics, and click on this link which will start the web console for you. And from this point on, you will do step by step what is described here. And again, you will use the terminal inside the browser. And this is because it already includes everything needed for all the command lines of Knative, of kubectl needed for the lab. So you don't need to install everything. And after that, step by step, you need to actually first find your user and password that you will be asked to do here. The next step is actually how to find the Cloud Shell that I just described, and you will be able to run it without the need to install anything. And the third step, and it's explained all here how to run. The third step will be how to install Knative on your Kubernetes service. And again, it is described with a lot of details, and you just follow step by step of how to do that, and it's really easy to do. And what I would like to show now is actually the lab. So again, you need to follow lab 1, lab 2, and lab 3 for my Knative Gitbook. And with that, it will show you how to get yourself a cluster, how to do the first step, and to install the Knative on the OpenShift cluster. And then we'll go to lab number 4, that will take you to the Knative lab that I will now show step by step how to run. And by the way, this lab is actually deploying a Fibonacci service that we have 2 revisions. The first revision starts from the first argument 1, meaning for Fibonacci is like each argument is the sum of the previous 2 arguments. So if you start the Fibonacci from 1, so the first 4 arguments is 1, 1, 2, 3. But we have another version of this service that we will deploy later that starts from 0. And this is how we will demonstrate the revisions in Knative. So let's see how it works. So, and from this point, I will show you this on my CLI, but it's again copy and pasting everything, and everything is really described in a way so you can run it later. So I will go into my command line to my terminal, and by the way, because I'm using my CLI, my terminal on my local machine, and not as you will use it on your browser, I had to install all the CLI commands of Knative, and I did it here just to show you. But again, you don't need to do that because you are using an already prepared terminal that is part of the Open Lab. So when I logged into my cluster and I ran the kn command, it was not there, so I installed it. And after I installed it, when I again wrote kn, I found that I have this a command. But again, you don't need to do that because you are running inside the browser on a terminal that we already installed everything for you. The OpenShift CLI, the Kubernetes CLI, the IBM Cloud CLI, and the KN CLI as well. So let's see how we actually deploy our service. So the first thing after we logged in, and you will get all the commands again, you just need to do copy and paste. And let's create our first service. So just copying the command from the lab, kn service create fib knative. This is the name of the service. And we would like to use the image fib knative. And what will happen that Knative will create the service, the deployment, the replica set, and everything needed so our service will run, and it takes a few seconds, and it configured everything. And you can see that fib knative was created for us. This is the revision. It's the first revision, and this is the URL that we can use. We will export this URL to the My App URL, so it will be easier for us to run it later on. And when we run the command kn service describe our service, again, everything is on the lab. You just need to do copy paste. You can see that we have a service called fib knative on the kn lab namespace that I was inside this namespace. It was created 2 minutes ago. This is the URL. This is the route. And there is one revision that was created 2 minutes ago. And currently, everyone that will call this URL will 100% of them will go to this only revision that we just created. When we'll call this service, when we'll call this service using the URL, curl URL with the environment variable, with a parameter, with our export, with our URL, and we will say that we want to run it with 5 arguments. We can see that the answer from this service was 11235 because this revision is starting from 1. This application, this container image is a Fibonacci that starts from the first argument that it is 1. Now we would like to do an update, and we'd like to give this revision a specific name, and we'll run the command kn service update fib knative, which is the service name, and we'd like to give it a revision name called fib knative 1 because the first argument is 1. And again, we see it takes a few seconds, and Kubernetes and Knative will create a new revision for us, and the URL stays the same URL. And when but we created a new revision, and now the name of the revision is fib knative 1. The next thing is that we would like to update this service and use another container image that this time, this image is more or like the same like the previous Fibonacci, but this time the first argument starts from 0. So it's actually another container image that we want to now deploy. So we run the command kn service update, fib knative, it's our same service, but this time we want to use the image, a different image, fib knative vnext, which is again our program that this time we start from the argument 0, and we want to give this revision name that is called fib knative 0. Again, it takes a few seconds and there's a new revision. Now, if we ask to see which, to describe the service, kn service describe fib knative, we can see the URL is the same URL, and we can see that currently the last revision that is operating is the third one, because we had the first one, and then the second one was just giving it, the first revision, a specific name, and then the third revision was using a container image that starts from 0 instead of 1, but this is the last revision, and 100% of the calls that will go to this URL will be routed to the third revision. And the third revision is the new one that starts with 1, and we can see that it's new. Now let's call this service again with the same URL with 5 arguments, and we can see that we have 5 arguments, this time starting from 0. So you see 0, 1, 1, 2, and 3 instead of before 1, 1, etc., etc. So you can see that we are actually getting the new revision in a very easy way. And again, we just told Knative that we want a new container image to be used. We didn't declare any resource, any deployment, any replica set. Things are really, really, really easy. The next thing that we would like to do is do some traffic splitting. And for that, we will say Knative. We would like to do traffic splitting, 10% to the 0 version, which is the new version, and 90% to the previous revision. And again, let's see what happened. This time it's just traffic splitting. And when we'll run again the command kn service describe fib knative, we will see that we actually now have 2 revisions working. The revision 3, which is the newest one, is getting 10% of the traffic, and revision 1, which is the older one, is getting 90% of the traffic. And when we will call those revisions, and we'll do a loop, and each time ask just for the first argument, but run it again and again, we can see that something like 90% of the time we'll get the old revision, which is 1, starts with the argument 1, and a smaller amount of calls will be routed to the newest revision that starts with the argument 0. Okay, so we see the traffic splitting really works, and all we need to do is just do traffic splitting using a very simple knative command. The next thing that we want to do is give a specific route, a specific URL for both revisions. So not only they are splitted, 90 and 10, we can also call specifically a specific revision with a specific URL. So with that, we'll run the command again, kn service update, fib knative, tag, fib knative 0, which is the revision, it will be tagged with 0, and another tag for the revision 1 with the tag 1. Okay? And now, when we'll describe the service, kn service describe fib knative, we'll not go into all those details, but at the end, we can see that we have 10% for one revision, 90% for the next revision, and you can see that they also got a specific URL that now starts with one starts with 0 and one starts with 1, but we also have the general URL for the specific service. So if we'll continue calling the general URL, we'll get 90% of a specific revision and 10% for the next revision. But if we want to call specifically a specific revision, we can call it with the URL that starts with 1 or 0. And actually, this is what we'll do in the next step here. So I exported those two URLs, and the first time I called the 0 URL, and the next one is I called the 1 URL, and you can see that there's a difference. And please excuse me for 1 second. Sorry. Okay, the next thing is I would like to show you how we also work with kubectl command. So if I run the kubectl get pods, you can see which is a kubectl command. And first of all, you can see that we can use kubectl command. And the second thing is that you see that we had a few, two revisions running, the revision 1 and revision 0. But then since we started, I didn't call them again and again. So after a few seconds, they start to terminate until there's no resource at all being used. So again, at the beginning, you see both revisions are being used and there's pods for them. And then little by little, they start to terminate until after 2 minutes, actually, there's no revision. Actually, there's no containers and no pods running. And now let's see the same things that we did with the Knative command being done with the kubectl command, which is the same. So kubectl get configuration, we see the service kn fib knative, and the last revision is the one with the 0. And if we run the command get configuration, we see all the configuration that was created for this service with the revisions, which is the last revision, etc., etc. When we want to look at a route, we also can run a kn route and see again that we have again two revisions, one that 10% and one with 90%. And we look at the kubectl get revision, we can see those 3 revisions that we created. You remember the first one was without a specific name, and then the second one was the same actually container, but just with a new name. And the third revision was with a specific name and a new container image. And actually, this is more or less the lab I wanted to show you. And let's see if we have questions. No, you're all good. Okay, so from my point of view, this is what I wanted to share with you today. And first of all, please answer the short survey with the link that I've just posted. And I suggest that you run the lab on your own time and see that you can run those Knative commands. While you are running this lab, you can also run the Open Lab labs to learn more about OpenShift. You will be able to listen to the recording of the session. It will be shared on the same link that you are just using. And if there's no more questions, I will end up here.
There is one question. They asked if there is any eventing example, if you have.
I will add it. Actually, I will look for it. I have. I think the lab also have an eventing way. Let's see if I'm not wrong, and if not, I will add it to the. Let's see. I think. Let's see. This one we don't need. No. This is tag the layer. Yeah, I think at the end of, if you follow not only the labs I mentioned, but also exercise 6 and 7, there's also a sample to how to run Knative eventing. So there's a sample there. Okay, but I will also post my email if you have further questions and you would like to get some more information or clarification. Please write to me. And with that, we'll end this session. Hope to see you on our coming sessions. Actually, on the 17th, we have an IBM Code Engine session that is based on Knative, but without actually the need even to create yourself a Kubernetes cluster, and really pay only for real resources that you're using. So thank you and goodbye.